Welcome to The Explainer. Today, we're tackling a massive but honestly often totally invisible bottleneck in food and beverage manufacturing. We're going to dive right into why relying on just a micron rating is a complete trap and how selecting the wrong membrane chemistry might literally be secretly throttling your production output right now.
So we really need to ask this critical question right out of the gate. Is your membrane filter quietly choking your production? Look, we see it all the time. Facilities buy filters based purely on retention performance, right? But here's the harsh reality. You could have two filters with the exact same 0.2 micron sterile rating, but they will perform drastically differently on the floor if their polymer makeup doesn't match your process fluid. If the chemistry is wrong, your output is going to suffer immensely, even if that filter is technically doing its job catching microbes. And when you choose the incorrect material, well, it leads directly to some seriously painful bottlenecks. We're talking about choked flow rates, meaning you are literally processing way less liquid per hour. Then there's the lost product yield, where vital proteins and flavors get stuck to the filter. That's just straight-up product you can't sell. And honestly, maybe worst of all, you're facing costly downtime because these filters fail prematurely when they get absolutely destroyed during routine hot chemical cleaning cycles. To fix these output problems, we're covering the agenda. First, PES, the aqueous standard. Second, PTFE, the gas and chemical master. Third, PVDF, the versatile middle ground. And fourth, comparing the big three. Before we jump into the specific materials, let's quickly touch on the foundational science here. It all boils down to hydrophilic versus hydrophobic. A hydrophilic, water-loving membrane wets super easily with water-based liquids. On the flip side, a hydrophobic, water-repelling membrane repels moisture and absolutely excels in gas and aggressive chemical environments. So if you stick a water-repelling filter in a water-based beverage line, yeah, you're going to struggle to wet it, your flow rates will totally tank, and your output will grind to a dead halt. It really is that fundamental.
Let's kick things off with Section 1, PES, the aqueous standard.
Okay, so PES, or Polyethersulfone, translates directly to your bottom line. Because it's naturally hydrophilic, it wets incredibly easily with aqueous products. Because of this, it delivers highly economical, continuous production. You're getting massive, high flow rates at relatively low pressure drops, and at the same time, it has these really low adsorption characteristics. That means it preserves your product's crucial flavor compounds, colors, and nutritional ingredients instead of just trapping them and ruining your yield. If you're filtering water-based liquids, think beer final filtration, wine bottling, bottled water, or dairy ingredient filtration, PES is absolutely your high-output hero. It keeps the liquid moving fast and really minimizes product loss. But, it does have a fatal flaw. If you expose PES to highly aggressive solvents, strong oxidizers, or really harsh chemical cleaning systems, it's going to degrade fast. And that forces you to stop production and swap out filters, which totally kills your efficiency.
And that leads us perfectly into Section 2, PTFE, gas and chemical master.
So while PS is your water-based workhorse, PTFE, or Polytetrafluoroethylene, operates in just a totally different world. It is fundamentally hydrophobic. It's incredibly difficult to wet with water. What does that mean for you? Well, using it for standard beverage filtration will absolutely kill your output. But because it repels moisture like a champ, it's practically invincible against wet environments and highly aggressive chemistry. It's the ultimate sterile gas and chemical filter, contrasted right against PES, which is your ultimate aqueous liquid filter. Out in the real world, this unmatched resistance makes PTFE the absolute master for things like sterile venting. Think about your fermentation tanks that really need to breathe as volumes and temperatures fluctuate. PTFE allows that sterile airflow while totally blocking airborne bacteria. And again, because it's hydrophobic, it's not going to get clogged up by condensation. Plus, PTFE easily survives repeated blasts of hot caustic cleaners, strong sanitizers, and solvents. It literally prevents output-killing downtime in the most extreme, aggressive environments in your facility. But what if your process falls somewhere in between pure water and highly aggressive chemicals? That brings us to Section 3, PVDF, the versatile middle ground. Polyvinylidene Fluoride, or PVDF for short, balances broad chemical durability with extremely gentle product handling. It occupies this really valuable middle ground in manufacturing, effectively bridging that functional gap between PES and PTFE. It offers much broader chemical compatibility than PES, but remains way more versatile for liquid filtration than PTFE. And the really amazing part, it's available in both hydrophilic and hydrophobic forms, which makes it an incredibly adaptable tool for dodging those highly specialized bottlenecks. Now, PVDF is generally going to have a higher price tag, but it is so worth it because of its incredibly low product absorption. If you're processing highly sensitive, high-value liquids, we're talking functional beverages, nutraceutical drinks, biological fermentation broths, delicate enzyme solutions, or botanical extracts in mixed aqueous alcohol systems, PVDF is the way to go. It ensures high product recovery, it protects those delicate active ingredients and complex flavor profiles from getting accidentally stripped out of your product, making sure you maximize that high-value output. Let's bring all of this together in Section 4, comparing the Big Three. When you look at how the Big Three stack up head-to-head, it just becomes instantly clear why a one-size-fits-all approach is a recipe for reduced output. Seriously, if you just buy one type of filter for your entire plant, you are throwing money away. PEZ dominates cost-effective, high-volume water flow. PTFE completely takes the crown for sterile gas and surviving aggressive, hot chemical cleaning. And PVDF, it sweeps in to fill those highly specialized process gaps where low binding and chemical versatility are an absolute must. You have got to deploy them strategically. Our source material captures this whole concept perfectly with this quote. Rather than asking which membrane is best, manufacturers should instead ask which membrane is most suitable for the specific application, right? Maximizing your facility's efficiency, protecting your product yield, and avoiding those crippling flow bottlenecks is entirely about matching the specific polymer chemistry to the exact task at hand. There is no magic best filter, just the right tool for the job. So as you evaluate your operations today, I'm going to leave you with this final, pretty critical thought. Which membrane chemistry is actually running in your facility right now? Don't just glance at the micron rating on the box. Check your housings, verify those polymers, and ask yourself, are your current membranes truly the right ones for your process? Are they driving your output forward, or are they quietly, invisibly holding it back?